Good evening, everyone. Let me to introduce myself briefly. I am Mariam Tangarfa, and I am a PhD student in Analytical Chemistry and Environment at Mohammediya School of Engineering at Aouragh. Today, I'd like to talk to you about my presentation entitled The Optimization of the Adsorption of the Tannic Acid on the Fluorite Mineral Surface using a Response Surface Methodology. Introduction. So, fluorite is an important valuable mineral to produce hydrofluoric acid, but this mineral can be often found underground with calcite in ore deposits. Fluorite and calcite minerals are characterized by similar physicochemical properties, so their separation is difficult. So, to separate between these two minerals, flotation is the most commonly used method, and this technique is achieved by tannic acid adsorption onto fluorite. The objective of this work is to optimize tannic acid adsorption onto fluorite using a central composite design of a response surface methodology. First of all, I begin by experimental setups. I continue by statistical modeling and optimization, and I finish by a conclusion. Experimental setups. So, to study tannic acid adsorption onto fluorite, we added 1 gram of fluorite to 100 ml of required concentration of tannic acid solution at a fixed pH and temperature. We filtered the obtained mixture, and then we analyzed it by ultraviolet visible spectrophotometry to determine the adsorption capacity using the following expression. To study the influence of physicochemical parameters on tannic acid adsorption onto fluorite, we chosen 3 parameters, including initial tannic acid concentration, pH solution, and temperature. Table 1 presents experimental range of independent variables and their real and coded values. We investigated the study according to a central composite design. The number of central composite design experiments is expressed as follows. So we obtained 17 experiments, including 3 center points. Table 2 presents central composite design and experimental results. Now we move to statistical modeling. To correlate between the dependent variable, in our case, the dependent variable is the adsorption capacity. So to correlate between the dependent variable and the 3 independent variables, we used a second-order polynomial model established as follows. We performed the statistical modeling using Box-Cox procedure, and we analyze it by analysis of variance based on 3 parameters: p-value, mean absolute error, and correlation factor. Table 3 shows analysis of variance results. As we can see from this table, all parameters are significant because they have a p-value less than 5%, except the last parameter that has a p-value more than 5%. Also, the model presents a p-value less than 5%, a low mean absolute error, and a high correlation factor. So this model describes well the studied adsorption process. Here we have the model expressed as follows. Now, after these results, I'm going to move to optimization setup. This figure shows contours of the estimated response surface. We can see that the adsorption capacity is highly dependent on initial tannic acid concentration and pH solution. So the adsorption capacity increases with increasing of initial tannic acid concentration, while the pH 5 is the optimal pH to achieve a high adsorption capacity. So the optimal condition results are presented in this table. So here we can see that the adsorption capacity of approximately 10 milligram per gram can be obtained using an initial tannic acid concentration of 175 milligram per liter, a pH of 5, and a temperature of 303 Kelvin. Here we have model validation results. So from this table, we can see that experimental and predicted adsorption capacity are very close. This means that the obtained model predicts very well the studied adsorption process. As a conclusion, experimental study of tannic acid adsorption onto fluorides was performed and optimized by response surface methodology. Tannic acid adsorption onto fluorides is highly dependent on initial tannic acid concentration as well as solution pH. Optimal conditions of adsorption process are 100 milligram per liter of initial concentration tannic acid and 5 of pH solution. So this study is an important preliminary step to study flotation behavior of fluoride via tannic acid. Thank you for your attention.